Alright, Chapter 10, Data Analysis and Probability. Study Guide. We have the population, unbiased Bayes sample, random sample, margin error, permutation, fractional, combination, geometrical, probability, commanding, compound, evident, overlapping, disjoint, complex of independent, dependent events, and conditional probability. 10.1 Populations and survey. A population is an entire group of people, animals, objects that you have found information on about. If you cannot collect information about every member of the population, you can use a smarter part or a smaller part or a sample of the population. Samples in bias. An unbiased sample accurately represents the population. A biased sample over represents or underrepresents a part of the population. Diagram below shows two samples of 12 out of a population of 96 students who were asked whether they are playing softball. They prefer playing softball or tennis. 3/4 of the population, or 72 students, prefer softball. In the top sample, the 3/4 of the students prefer softball. The same in the population. The sample accurately represents the population, so that it is unbiased. In the bottom sample, 1/2 of the students prefer softball. The sample does not accurately represent the population, so it is biased. So you have a total population, a biased, unbiased sample, and which underrepresents the population. And a bias sample. Eliminating biases. To obtain an unbiased sample of populations, you must be careful that way you choose your sample does not introduce bias. Also, in general, large samples is most likely to be unbiased than a small sample chosen the same way. Alright, survey questions. If in a survey, not only must people surveyed be chosen carefully, but the questions themselves must be worded carefully, otherwise the result might reflect the true views of the surveyed, even in a larger, well-chosen sample. Survey question may not hint that their preferred answer. Survey setting of the questioner can influence the result. Examples: people asked in front of the news camera, the recycle might be more likely to answer yes than if they asked, given the answer of the anonymously. Making predictions. Samples are carefully chosen, avoiding giving biased results. Also used to make predictions about population. Exercise. 10.2 Sample and margin of error. Classify sampling method, final sampling, and errors. What are the ways in which you can select your sample? Are there ways to increase likelihood of your sample being unbiased? Some sample types will discuss below. We have a convenient sample, easy to reach members of the population selected. For example, you could survey the households on the street plus the two of your front friends. Self-selected members of the population volunteer to be included. But example, if you could leave surveys doors of all houses, you would use that you return to you. As a systematic sample pattern where you select members of the population. For example, you could survey every fourth household in the neighborhood. A random sample, each member of the population equally likely to be chosen. For example, you could write each address on a slip of paper and draw slips from a bag. Biased and unbiased samples. In general, the random sample is likely to be biased in the situation above. The systematic sample is unlikely to be biased. Convenience and self-selected samples are likely to be biased above. The convenience sample might be overrepresent people very close to a news store. Self-selected sample might overrepresent friends or people with strong feelings. Sample error. Every random sample can be given a biased result just by chance. Margin of error of the sample tells how close you can expect with a measure of population to be measured found with a random sample taking the population. Margins of error formula. This particular random sample size with a number of a large population use the following formula to approximate the margin of S. Margin of error is equal to plus or minus 1 over the square root of n, with the p percentage of the p% of sample responds a certain way that is likely to intervals of per people percent minus the population, whatever. Notice if the margin error formula sample size of the denominator with a fraction larger sample, the smaller the beginning of the error, the more confident in the sample that represents the population. Alright, 10.3 Transforming data. In studies of study, you will learn how to examine a data set, measuring change of the increase of the decrease of data values, constant amount, when you multiply them by a constant factor. Studying a transformation, you look at the measure central tendency, mean, median, and mode, measures the dispersion range and the difference between quartiles. Discounts, use the information below. 10.4 Fundamental counting and principles and permutations. Alright, goal. Using the fundamental counting and principle permutations, you can find the number of meal possibilities at the cafeteria. How much lunch specials can you choose if you could choose chicken, pasta, or fish, main dish, soup, and salad on a side dish? One way to answer the question of the tree diagram is shown below. For each 3 main dishes, there are 2 possible side dishes for a total of 3 times 2, 6 different lunch special choices. Fundamental counting principle: 2 events, and one event occurs in m ways, another event occurs in n ways, and the number of the ways is both events occur with m times n. 3 events, if one can occur with m ways, and the second event n ways, and the third event p, then the number of the ways all 3 events can occur is m times n times p. Counting principle also extends to 4 more events. The counting principle also extends to 4 or more events. Permutations: an order instead of object. Permutation of objects by fundamental counting principles. There are 3 times 2 times 1 is equal to 6 permutations of 3 objects. For example, there are 6 permutations of the letter A, B, and C, A being red, B being blue, C being C. An expression of 3, 2, 1 can also be written as 3 to the factorial symbol, which reads 3 factorial in general number of permutations of the n to the distinct n to the factorial. Permutations of the n distinct objects, n to the factorial is equal to n times n to the minus 1 times n minus 2 to the plus or minus 3, 2, 1. So example would be the factorial of 4 factorial would be 4 times 3 times 2 times 1, 5 object factorial, 5, 4, 3, 2, 1, all multiplied. 6 factorial, 6, 5, 4, 3, 2, 1. Using factorial notation. In this part B, above ordered group of 3 skiers taken with a group of 8, the permutation of 8 objects, n objects, and 3 at a time denotes 8, 3. The number of permutation of the number of objects at the rate of time denoted with the number of objects times the permutations at the rate is given in the following formula. Number of permutations at the rate is equal to the nth factorial over n minus the rate factorial. Alright, 10.5, combinations of Pascal's triangle. Alright, use combination to relate Pascal's triangle. How many groups of 3 can be chosen from 4? Number of orders of 3 student volunteers can be chosen from 4. Nonprofit organization worksite, the number of permutation 4 objects taken from 3. So we have 4 the number of objects at the permutation of 3, the rate, equal to 24. Because if there are 3 students that are also given the same task, the order in which they are chosen does not matter. The combination selection of the rate of objects from the group of the nth number of objects where the order is not important. Combinations of the nth objects taken as the rate as the time. The number of the combinations of the nth distinct objects at the taken are at the rate of time is indicated with the nth to C. Are as given as the following formula, and the number of distinct objects of the combination rate is equal to n to the permutation rate over the rate factorial equal to n factorial over n minus the rate factorial times rate factorial. Alright, 10.6, Introduction to Probability. Goals: find theoretical and experimental probabilities. How likely is it that a song chosen on random will play in a particular order? Questions involving how likely a particular thing will happen and answer the terms probability. Consider a list of songs playing in a random order. All this possible order songs can be in or in outcomes of an event with a particular outcome group of outcomes. For example, the favorite song plays at last and is an event. Probability of an event is number 0 to 1. It tells you how likely it is occurs if the event must occur. If an event must occur, its probability is 1. If it cannot occur, its probability is 0. If the event is equal to or cannot is equal likely to occur or not, it's probably 1/2. So if P is equal to 0, event cannot occur. P is equal to 1, event must occur, and increased likelihood event is equally likely to occur or not occur. Probability can be expressed in a fraction, decimal, or a percent. Theoretical probability of an event. When all outcomes are equally likely, the theoretical probability that an event A will occur is the probability of the event A is equal to the number of outcomes in an event A over the total number of outcomes. Theoretical probability of an event is often simply called probability. Alright, experimental probability is not always possible. Convenient to find an even theoretical probability by conducting an experiment survey. By looking at event history, you can find the experimental probability of an event. Given the number of trials, experimental probability the event A will occur. Probability of event A is equal to the number of trials where A occurs and total number of trials. Experiment and trial experiment can be simple as flipping of a coin. Survey the experiment which experience responds to singly tried. Geometric probabilities. You can find probabilities based on ratio of two lengths, areas, and volumes. These are called geometric probabilities. That was 10.6. 10.7. Probability of compound events. Goal is to find the probability union intersection of events. The union of events A and B is all the outcomes in either A or B. Intersection of A and B is all the outcomes that are shared, both A and B. Union and intersection of the two events is called a compound event. Two events that the outcomes common are overlapping events. Two events that have no outcomes are common disjointed events and mutually exclusive events. To find probability union two events, you need to know the event share any of the outcome. Overlapping events. If A and B overlap events, the probability A and B is not equal to 0. The probability A and B is probability A or B is equal to probability A plus probability B minus probability A and B. Disjoint events A and B is a disjoint event. Probability A and B is equal to 0, and probability A or B is equal to probability A plus probability B. Or complements. Complement of the events consists of all the outcomes not in an event. For example, if an integer from 1 to 10 is chosen at random, complement of the event integer is even and the integer is odd. Probability of the complement of the event. The sum of probabilities of the event and the complement is 1. Probability of A event is plus probability of not A event is equal to 1. So probability is not getting A is equal to 1 minus probability of A getting A. Probability of A. Alright, 10.8. Probability independent events. Two events. Independent occurrence of the one event does not affect the occurrence of the other. Two events dependent of the occurrence of one event does affect occurrence of the other. The probability of both two events occur depends on whether the events are independent or dependent. Consider the probability of the drawing of blue marble random with a bag after the first drawing with a green marble. Therefore, how does whether the replace of the green marble affect the probability of drawing a blue? Independent events, the probability of drawing a blue is the same as which it has been if it has not been chosen in the first marble. Dependent events, probability of the drawing blue is different from what it would have been if you had not chosen the first marble. Alright, conditional probability. Two dependent events, A and B, are probability that B will occur given that A has occurred. A conditional probability that B given an A is written probability of B is given from A. Probability independent events. Independent events, if A and B are independent events, then probability of both A and B occurring, probability A and B equal probability A and times probability of B. Dependent events of A and B dependent events, then the probability of both A and B occur, probability A and B, or probability A and probability of B, and I forget that, dependent on A. Notice that the events of A and B are independent, and that probability B and A is just a probability of B, so that the first formula box is a special case of the second. Three or more events, you can determine the formula probability of independent dependent events of three or more events. For example, the three independent A, B, and C, probability A, B, and C is equal to probability A times probability B times probability of C. Alright, chapter summary, chapter 10, summary and review. We did population sample, unbiased bias sample, conveniency sample, self-selected sample, systematic sample, random sample, margin error, permutation, factorial combination, Parcell's triangle probability, theoretical probability, experimental probability, geometrical probability, compound event, overlapping event, disjointly, mutual exclusive event, complements of an event, independent events, dependent events, and conditional probability. And we're getting to chapter 11, discrete mathematics.